Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video, we will explore some more interview questions on embedded systems. So please watch this video till the end, and very important questions I'm going to discuss in this video. And if you're a new viewer to my channel, please subscribe my YouTube channel and share these videos to your friends and colleagues and click on like button. Let us start the video, embedded system interview questions, and it's a session number 3. The 11th question and the first question of today's session. So, what do you mean by watchdog timer and why it is used in the embedded system? So, this is a very important thing you should know. What is the watchdog timer and why it will be used in the embedded system? Answer, you can see here. The watchdog timer is a hardware timer and it is going to be a countdown timer, and this watchdog timer is used to protect your microcontroller whenever your software and hardware fault occurs in your embedded system. Whenever your software or hardware is not able to respond properly, then the watchdog timer will start count down, and when it reaches with a 0 or when it reaches with a minimum value, it is going to reset your microcontroller and it will protect your complete embedded system. So these watchdog timer will help and increase the reliability of embedded system by automatically recovering the faults. So that means watchdog timer is used as a safety circuit in our embedded system. The next important question what you can expect in the interview is what is memory mapped input output in an embedded system, or what do you mean by memory mapped input output in a microcontrollers? Okay, so what is that? First I will show you one simple memory mapping, later I'll discuss. So let us assume this is my memory. So in this memory, so we have, you can see here, so we have a ROM here, we have a RAM here, we have RAM here, and we have a ROM, and this is having its own address, you can see here on the other side, right? And also you can see in the down bottom second part of the memory, so we have peripherals here. Okay, so we have our main memory, RAM and ROM, and along with we have peripherals here. So that means, what do you mean by memory mapped input output? Memory mapped input output means the peripherals are mapped as a memory. So whatever you're seeing, the memory peripherals like what SPI to C and so on, these things are going to be, registers with associated with these peripherals are mapped to the main memory as a part of main memory, and that is called as memory mapped input output. What is the advantage of this? The processor easily can interact easily without any additional delay, like how it is interacting with the memory. This is the advantage. Okay, now let us see the answer here. Memory mapped input output is a method where the peripheral devices and its registers are mapped as a memory, and a similar address space will be used how we are going to use for RAM and ROM, allowing CPU to use a standard load and store instruction for input output operations. This is what I told, right? So for CPU it will become very easy to interact or to connect with the registers of your peripherals using load and store instructions, and execution speed also will be more, accessing speed will be more. Okay, so this is going to enable the efficient and high-speed communication with the devices, like all embedded systems, not only graphics cards here, all embedded system applications. This memory mapped out input output will be very much useful. The next important question in the interview you can expect is what is pipelining in embedded system? So pipelining in embedded systems plays a very important role in order to increase the speed of execution. What do you mean by pipelining? Pipelining means the parallel execution of multiple instructions is called as pipelining. You can see here. So at this point and at this point, so we have two important things. One is 3-stage pipelining and one is five-stage pipelining. In this 3-stage pipelining, 3 instructions are executing parallelly, and in 5-stage pipelining, we're executing five instructions parallelly. What is the advantage of this? Pipelining will give you which will increase the speed of execution. Throughput will increase. Execution speed will be more compared to system without pipelining. Okay, now let us see one by one what it is. So in embedded system, pipelining is a hardware mechanism which is used to increase the instruction throughput. Instruction throughput means instruction execution speed. Okay, so instruction throughput by overlapping the execution of multiple instruction. That's what I told. Multiple instructions are going to be executed in a single cycle is called as pipelining. So simple sentence, simple answer. So multiple execution of multiple instruction in a single cycle is called as pipelining. Popularly there are two things. One is three-stage pipelining and one is five-stage pipelining. In three-stage pipelining, we will have three cycles or three stages: instruction fetch, decode, and execution. And in case of five-stage, we will come with a memory and write back. What do you mean by instruction fetch? Instruction fetch means it retrieves the instruction from the memory. Very straightforward definition. Instruction fetch means it retrieves the instruction from the memory. Next point, instruction decode. It's going to interpret the operation and reads the register. That means it's going to decode its operation. The processor will decode its operation. Third one, execution. Execution means exactly the execution of your instruction, whether it's an addition, subtraction, multiplication, and so on. Then the fourth step, memory access. That means here you can see the memory, right? So whenever you want to interact with the memory, we have to go for memory operation. The memory operation is used to read or write the data from the memory or to the memory is called as memory operation. Finally, write back. Write back means the finally result, whatever you got, that result will be written back to the register file is called as write back. So like that, in our embedded system, most of the controllers will go with either three-stage pipelining or five-stage pipelining to increase the execution speed. So one more important question what you can expect in the interview is, what is serial communication and why it is used? So answer, let us see here. The serial communication means, you can see the diagram here. Serial communication means bit by bit transmission from one source to other destination. So here I have a transmitter and here I have a receiver. Bit by bit transmission is called a serial transmission or a serial communication. What is the advantage of the serial communication? Serial communication required very less hardware. Maybe one or two wires or one or two connecting terminals we required to transmit and to receive the data. Okay, this is a very big advantage. In embedded system, we want to reduce the size as much as possible. The serial communication in embedded system is a method of transmitting data sequentially, nothing but serially, one bit at a time over a single wire or a pair of wire is called as serial communication. It is widely used in our embedded system, IoT devices, industrial automation, and so on, in order to reduce the physical connectivity. Okay, so this is called as serial communication, and most of our embedded protocols such as UART, SP, and I2C CAN all are serial communication protocols. UART stands for Universal Asynchronous Receiver Transmitter, SPI Serial Peripheral Interface, and I2C stands for Inter-Integrated Circuit. One more important question, what you can expect similar to serial communication. What do you mean by parallel communication and why it is used in the embedded system? Very straightforward answer. In case of parallel communication, we will be transmitting group of bits from receiver to transmitter to receiver. Group of bits will be transmitted in a single transmission, and this parallel transmission or a parallel communication required group of hardware pins. You can see here in the previous slide we have seen only one or two connecting lines, but here in case of parallel communication we require a group of pins. Minimum 4 pins or 8 pins we require to transmit 8 bits of data. Okay, example for this parallel communications in our day-to-day life is LCD interfacing, sound segment interfacing, stepper motor interfacing. These are all the examples for your parallel communication. And along with that, there are some parallel communication protocols are there. One is called PCI, that stands for Peripheral Component Interconnect. This is a parallel communication protocol. Then we have SCSI, that stands for Small Computer System Interface. Then we have ATA, Advanced Technology Attachment. These three are the like widely used parallel communication protocols. Usually these things are used in our computers or in our laptops. One more very important question what you can expect in the interview is DMA. Most of microcontrollers will come with a DMA. And what is this DMA and why it is required in a DMA and what is the use of this DMA? So this point I'll be discussing in this question. What is DMA? That stands for direct memory access, and how it is used in our embedded system. So first we will understand one scenario. So let us consider I have a memory here and I have some peripherals like a ADC, CAN and UART. I have a peripheral and I want to transmit a data. I want to transmit a data from memory to the peripherals like this. I want to transmit some data from memory to the peripherals. How it is possible? It is possible through the CPU. That means CPU has to take over and CPU has to involve in a data transfer. That means the CPU has to connect, or it has to take the data from the memory and then it has to connect it to the peripherals, and like that you can transfer the data from memory to peripherals. This is the one way. But during this transmission, what will happen? The CPU has to CPU has to execute these instructions and the main program will be halted, right? So if you have a main program and if you want to transmit the data from memory to peripheral, so what will happen? The CPU is going to waste the time, or CPU will be busy in data transmission, and other main code or a main program will be under halt condition. So to avoid this, scientists they invented one more concept called as DMA. DMA stands for direct memory access. Without CPU intervention, DMA can able to transmit data from memory to peripherals or peripherals to memory. That is what you are seeing on the screen. Okay, so this DMA plays a very important role, and this DMA is controlled by CPU. Nothing but your processor is going to give a commands to DMA, and once the command is received from main CPU to DMA, DMA will get activated, and the DMA is responsible for they're responsible for data transmission from memory to peripherals and even vice versa. Okay, now if you see here, so what is the first thing? The CPU gives the following commands to DMA. So what do you mean by DMA? First of all, DMA stands for direct memory access. Okay, and this DMA is a small microcontroller, a small controller which will be residing in the microcontroller. That is called as DMAC, or it is also called as DMA controller. So main functionality of this DMA controller is to transfer the data without CPU intervention. Okay, now you can see here CPU gives the following commands to DMA. The first point, so CPU will give source and destination address. Okay, and then starting and end address. That means from which source to which source you want to transmit, whether you want to transmit from memory to peripheral or peripherals to peripheral or memory to memory. So it is possible in all the way, memory to peripheral, peripheral to memory, peripheral to peripheral, memory to memory. All possibilities it is available. So that's why the source and destination, the processor will give source and destination, starting and ending address, and then start command. These three important commands will be given by the CPU. That is called as handshaking mechanism. Okay, so CPU will give a commands to DMA, and once the start command is given by the CPU and received by the DMA, DMA will continue with the data transmission. The DMA will trigger the data transmission from memory to peripherals, and it will your DMA will continue, and once the data transfer is completed, the DMA will send one acknowledgement or an interrupt flag it will set, saying that data transmission is completed. This is called as handshaking mechanism. So during this transmission, the CPU will continue with the main task. This is very important. This is what we wanted. The data transmission should happen independently without any CPU's involvement, is called as DMA. So CPU will continue with its activity, DMA will continue with its data transmission. I hope you are clear with the concept. Okay, now so what do you mean by DMA? So DMA stands for direct memory access in embedded system. DMA in embedded system is a hardware mechanism that allows peripherals like ADC, SPI CAN to transfer a data directly from a system memory without CPU involvement. This is what I have explained, right? So without CPU involvement or without CPU's intervention, the DMA will take care of transmitting data from peripherals to memory and memory to peripheral. Okay, and DMA, complete DMA operations are controlled by DMA controller, and that DMA controller is controlled by your CPU. The CPU will give different commands like start address, end address, source and destination, and start command. All these things will be given to DMA controller by the CPU, and the CPU will continue with the main program, and the DMA will continue with data transmission. So finally, what is the conclusion? It is going to improve overall system throughput, and it will increase the efficiency and speed of execution as well. So I hope you are clear with the DMA. So I hope even this video is clear to all. If you feel this video is an informative video, please click on like button, share to your friends and colleagues, and subscribe my YouTube channel.